Hello! In the second video of representations of data, we'll be looking at box plots and trying to visualise ways of viewing data. So this might be familiar from GCSE, but a box plot, also known as a whisker diagram, can be drawn to represent the important features of the data. In particular, it shows the median value. I'll have another go at spelling median in the middle there. And on either side of the median is the lower quartile and also the upper quartile. And a reminder about notation, this is often referred to as Q1 for lower, Q2 for median, and Q3 for upper quartile. And then we can see two bars, also known as whiskers, at the end. These are referred to as our maximum and minimum values, with an important caveat. Those are the maximum and minimum values that are not outliers. But we can see that in fact there is a smaller value than the minimum, but the fact that it's drawn as an X denotes that it is an outlier. And in this way, we can take a list of data and visualize it using 4 key points to visualize it as a box plot. Okay, let's have a look at an example to illustrate that. Okay, so use the stem and leaf diagram to work out Q1, Q2 and Q3 and whether there are any outliers, given that k equals 1.5. So I think I'll just remind myself of a formula that we talked about in the last video for outliers. We're going to say a lower outlier, or the lower boundary for outliers, is given by this formula here, Q1 minus 1.5 times the interquartile range. And we'll have a similar value for the upper boundary of an outlier, but this time starting with the upper quartile and adding 1.5 times the interquartile range. Okay, so now we need to find out the summary statistics for quartiles, the median and the interquartile range for this data set. Well, just to remind you of how this stem and leaf diagram works, the number 1, 0 is representing the value of 10. So if we count all the data points, I believe we've got 21 values there. So our formulas will be as follows. Q1 is for 21 over 4th value, which in this case would be 5.25, and remind that we round to get the 6th value. 1, 2, 3, 4, 5, 6. So we can say that the lower quartile, Q1, equals 24. In a similar way, we can work out the upper quartile. 3 times the total number of data points divided by 4, which would be the 15.75th data point. And again, we round this value, so we're actually looking for the 16th data point. And if we count those out, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 to get an upper quartile of 32. And then I'm sure we all remember the formula for the median, or Q2 is the n plus 1 value divided by 2, which in this case would be, well, there's 21 data points, so 22 divided by 2. We're looking for the 11th data point, which in this case would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 18. Oops, I beg your pardon, I misread that. That should obviously be 28. And my notation has failed as well. Q2 equals 28. And those three values can enable us to work out the interquartile range. The IQR would be upper quartile minus the lower quartile, which in this case would be 8. So let's find out these cutoff points for this data set. The lower quartile is 24 minus 1.5 times the interquartile range of 8, which would equal 12. And I'm going to work out the upper boundary at the same time. The upper quartile is 32 plus 1.5 times the interquartile range of 8 gives us a cutoff of 44. Okay, let's just clear that data in a physical sense. And let's see if there's any lower outliers. Are there any values lower than 12? Well, yes, I can see this value of 10 and 11 would be outliers. And in a similar way, we can find there would be any upper outliers. Are there any values greater than 44? And yes, we would have a value of 49. So we can write a conclusion that the outliers are 10, 11, and 19. Now let's try and represent that in a box and whisker diagram, also known as a box plot, below. Okay, so the first thing to do is to plot on our outliers. In fact, before we do that though, we need to label our axes and we need to say what it is we are measuring. So let's add a scale onto this. A scale of every medium square being 10 should work out quite nicely. Let's have a second attempt at that. And then I always like to do the outliers first. So I can see I've got an upper outlier of 49 and two lower outliers, one of 10 and one of 11. Next, I'm going to add the minimum and maximum values that aren't outliers. So our minimum value that wasn't an outlier is 15. That will be one side of the box plot. And then the upper outlier, so the maximum value that was not an outlier, is 43. And then we need to plot on our quartiles and our median. Well, our lower quartile was 24. Q1. Our median was 28. Q2. And our upper quartile was 32. And then just drawing this, finishing off the diagram, drawing the box. And the whiskers. And I'm just going to erase my working out where I labelled the quartiles and the median. And then we have a box and whisker diagram where we can see the outliers. We can see the minimum and the maximum value. And then in the centre, we can see the lower quartile, the median, and the upper quartile. Okay, let's do a similar question to reinforce those ideas. So in question 4, 60 students did a maths test. The test was marked out of 50. Results based on their data is as follows. We've got a lowest value of 15, a lower quartile of 29, a median of 34, an upper quartile of 37, and a highest value of 48. So, before we draw this box plot, we need to decide, are there in fact any outliers in this data set? We are told that using k equals 1.5, calculate whether 15 or 48 are outliers and draw a box plot to illustrate the data. Okay, let's remind ourselves we need to work out the lower boundary and the upper boundary. I'm going to abbreviate that to the lower boundary, LB. That is the lower quartile, Q1 minus 1.5 times the interquartile range. And a similar formula for the upper boundary, the upper quartile plus 1.5 times the interquartile range. So let's take a second to work out what the IQR is. Same formula as last time, upper minus lower. And we get an interquartile range of 8. So let's work out those values. The lower bound will be, I'm going to do it underneath actually, 29 minus 1.5 times 8 gives us a lower threshold of 17. And the upper quartile plus 1.5 times 8 gives a value of 49. So what can we say? Well, we can conclude there are no upper outliers. And then on the lower side, it's a bit more complicated. We know that there is at least one outlier, but because we don't have access to the raw data set, we don't know how many outliers, but we can confidently say that 15 at least is a lower outlier. And then I'm going to draw the box plot in the same way as last time. First, I'm going to do a scale. In this time, 10, 20, 30, 40, 50. We'll do our purpose as well. And this time it's meaningful data, so we'll label our axes as score out of 50. And outliers first, I can see we've got at least one lower outlier of 15 here. And then we'll do our maximum and minimum values that are not outliers. So 50. Oh, sorry, I beg your pardon. Our highest observed value was actually 48. And then we're going to, because we've got some lower outliers, we're actually going to do our cutoff of 17. So we've got our minimum and maximum values that weren't outliers. And then we need to add in our lower quartile of 29, upper quartile of 37, and the median as 34. And then let's tidy that up as a box plot. Okay, and that concludes our section on box plots. I will strongly encourage you now to have a go at the exercises in 3B.